focusing on measurement and data and the geometry standards. So for measurement and data, we're going to kind of break away from using non-standard units of length to standard units of length, feet, meters, etc. We're also going to relate addition and subtraction to length, work with time and money, and then represent and interpret data. So some things that are common with manipulatives, things that we can measure, analog and digital clocks, individual whiteboards with markers, measurement tools, concrete manipulatives, number lines, play money, etc. Just wanted to make a quick comment that we're going through these standards pretty quickly, and you have an entire year to cover what we're covering in 2 weeks. So clearly the things that we are covering is just the tip of the iceberg of what you will cover in your own future classroom. However, it gives you an idea of how the manipulatives work, and it starts the wheels turning on some possibilities for things that you can do in your future. But it also gives us an opportunity to see how standards are built from year to year and how they kind of build on each other. Zeus jumped 36 centimeters on his first agility jump competition. On his second jump, he jumped 45 centimeters. How many total centimeters did Zeus jump? How many fewer centimeters did Zeus jump on his first jump than his second jump? Ruger also jumped twice. The total of Ruger's 2 jumps was 95 centimeters. How many more total centimeters did Ruger jump than Zeus? So let's see, how many total centimeters did Zeus jump? So we know that when we jump, if thinking of a dog, I assume, a dog would jump up. So that's why I have my line going upward. His first jump was 36 centimeters. And his second jump was 45 centimeters. So we need to determine how many total centimeters that Zeus jumped. To do that, we can use our base 10 pieces to add these together. So we are going to combine measurement and data with numbers in base 10. All right, so we need 36. 1, 2, 3, 4, 5, 6. Okay, and we need to add 45. So we need to add 4 tens, 2, 3, 4, and we need to add 5. 1, 2, 3, 4, 5. Okay, so I see that I have 11 ones on my ones column, which means that I can exchange 10 of them for another long, so a group of 10. So I'm just going to get rid of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and exchange it for a 10. So that I see I have 1, 2, 3, 4, 5, 6, 7, 8 tens and 1 1, so 81. So 81 centimeters is what Zeus jumped. How many fewer centimeters did Zeus jump on his first jump than his second jump? How many fewer did Zeus jump on his first jump than his second jump? So I ideally want to know the difference between 36 and 45. So using the number line, we can start at 45, count back 5 units to 40, because that would be a milestone, and then 4 more backwards to arrive at 36. So we jumped back a total of 9 units. Or we could also count forward, starting at 36, jump 4 units to the milestone 40, and another 5 units to get to 45, for a total of 9 units that we jumped. So we can see that even though we're subtracting, there's two different ways that we can arrive at the same answer. So doesn't matter which way we did it, we still arrived at 9 centimeters. Ruger also jumped twice. The total of Ruger's 2 jumps was 95 centimeters. How many more total centimeters did Ruger jump than Zeus? So we know that Zeus jumped 81 centimeters, and we know that Ruger jumped 95 centimeters. So I put it on a number line here for us, an open number line. So with the open number line here, again using benchmarks, to get from 81 to 90, 90 being the benchmark, I need 9. And then going from 90 to 95, we need 5 more. So altogether, Ruger jumped 14 centimeters more than Zeus. One day, Frog and Toad were sitting together on a lily pad. Some lily pads were in line across the pond. In the morning, Frog hopped 3 lily pads away. In the afternoon, he hopped 2 more away. In the evening, he hopped another 2 more. Toad hopped 4 lily pads in the morning. He rested in the afternoon and continued 3 further in the evening. Frog said, "Toad, we ended up at the same place. Let's show each of their journeys and write a number sentence that reflects where they ended." So I have a number line here that actually is not an open one, but actually has the counting. So each number represents a lily pad. So on the first morning, Frog hopped 3 lily pads. So let's assume he started at 0 and we hopped 3. Then in the afternoon, he hopped 2 more. So now he's at the 5th lily pad. In the evening, he hopped another 2 more. So now he is at the 7th lily pad. Let's underneath show Toad's journey. So Toad jumped 4 in the morning. He rested in the afternoon and continued 3 more in the evening. So we see that their arrows or their jumps landed in the same place. So when we follow Frog's journey, he did 3 jumps plus 2 jumps plus 2 jumps. And that is the same as or equal to 4 jumps plus 3 jumps. After the introduction of money and the students have been able to touch, feel, and recognize the different values, students will use the notation such as, "I have $1 and 82 cents in my pocket." They have not learned the concept of the decimal point yet, so we need to keep them separate. Labeling them separately will help develop relationships among money for them. Also, the ability to develop an understanding that there are many different ways to build to a certain dollar or cent amount, just as there are with base 10 pieces. Think about the following. Can you make 47 cents using exactly 6 coins with either quarters, dimes, nickels, or pennies? So if you want to gather those coins and bring them in front of you, take a moment, pause the video, and see if you can, with just 6 coins, you can use quarters, dimes, nickels, or pennies, create 47 cents. Then come back, unpause the video, and we will see if you got the same thing I did. So using exactly 6 coins, we can use 1 quarter, 1 dime, 2 nickels, and 2 pennies. So we have 25 cents plus 10 cents, so we have 35 plus 5 plus 5 is 45, 46, and 47. Further, can you make 47 cents in 3 different ways using as many quarters, dimes, nickels, or pennies, any combination that you want? So 3 different ways. Pause the video, then we'll come back and I'll give you a few different solutions that I came up with. Okay, let's see if you have the same ones as me or perhaps something different. The 3 that I came up with was a quarter, 2 dimes, and 2 pennies. So 25, 35, 45, 46, 47. Or 4 dimes, a nickel, and 2 pennies. So 10, 20, 30, 40, 45, 46, 47. Or 3 dimes, 3 nickels, and 2 pennies. 10, 20, 30, 35, 40, 45, 46, 47. There are many different ways that you could do this. Here is just a few of them. You probably had something different. Handspan is the measure of distance from the tip of the thumb to the tip of the little finger, with the hand fully extended. A group of second graders measured their hands and reported their data to the teacher. As a class, the teacher recorded the data on a line plot. The data is shown as follows. So you see along the bottom is the hand length in centimeters. And then for each student, we just kind of added another dot so that we could count how many they are. So let's just start. How many are there? How many students were in the class? Well, I can count that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 students in the class. Are there any patterns that are observed? Do you notice anything? Most students have about the same hand span. There is one that is way bigger over on the far right hand side here. I wonder why that might be. And notice that the most students have the hand span length of 16 centimeters because it is the tallest. What are the largest and smallest spans? So it looks like the largest span, being the most centimeters, is 23. And the smallest hand span over here on the left is 14 centimeters. There were 3 students that had the smallest hand span. What is the difference between the largest and the smallest? So 23 minus 14 is 9 centimeters. We could use a line graph to do that, or we already have it listed here. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, counting right on that line plot. Use words to describe the shape of the data. To me, it appears taller in the center, like a mountain. It also looks like there is just that one peak. And some of us have larger hand spans than others. This is very subjective to what you or your students might see. Moving into geometry. This is a very small but impactful set of standards. But we need to reason more with shapes and their attributes, expanding more into polygons. So we're going to need 2- and 3-dimensional shapes, attribute blocks, pattern blocks, pangrams, geoboards, shapes, paper, objects to create. A polygon is made up of line segments that meet end to end. These line segments are called sides. No longer will we call them lines as in previous grades. Each side meets at exactly 2 other sides, and 3 sides never meet at the same point. A polygon always has as many vertices, no longer will these be points or corners, as in previous grades, as they do sides. A polygon always divides the plane into exactly 2 regions. One region is inside the polygon, and one is outside the polygon. So that must mean that it is a closed shape. Triangles are polygons with 3 sides. Quadrilaterals are polygons with 4 sides. Pentagons are polygons with 5 sides. And hexagons are polygons with 6 sides. We're not talking regular quadrilaterals, regular pentagons, or regular hexagons. We are just identifying the sides and how many sides there are, so identifying the polygon based on the sides. I assume that you print out the lesson PowerPoints, so take a moment, pause the video, and complete what I have listed here. Color the insides of all the triangles blue, color the inside of all quadrilaterals red, color the inside of all pentagons orange, and color the inside of all the hexagons green. Circle all the shapes that have sides that are equal. Take a moment, pause the video, and then we'll reveal the answer. Okay, let's find the answer out. So it should look something like this. Okay, you may have needed to take a ruler and measure sides to see if they all are equal, or used a side of a piece of paper and marked where they were to verify. And notice on the very bottom there is nothing that's colored with that kind of box, because notice that it's not closed. So all of the sides don't meet one another. And since it's not closed, it's not considered a polygon. Again, I hope you printed off this so that you can do the activity as we go along here. So using the rectangle here with the hashtags, draw a grid on the rectangle by connecting each mark to the one directly across from it on the opposite edge. It should look like this. The grid separates the rectangle into many little squares. How many squares are there? Well, I can count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 little squares. There are 5 little squares in each row. Count by 5s to find how many squares there are in the entire rectangle. So 5, 10, 15 of them. So this is another way that we can count how many there are. Is there another way we can count to determine how many squares there are? Well, instead of going by rows, perhaps we can go by columns. So we can count by 3. 3, 6, 9, 12, 15. Special note that at this age, students aren't required to know how to count by threes, but it's a good opportunity to show that that pattern does exist. One number sentence which shows the total number of squares is 3 plus 3 plus 3 plus 3, so 15. Take a moment, pause the video, and write another number sentence that shows the total number of squares. I also came up with 5 plus 5 plus 5 is 15. Or 1 plus itself 15 times for 15. This is a great introduction and to multiplication. Even though they don't recognize that this is multiplication, they will recognize once we get to multiplication that it is repeated addition. Using the same cut pattern for each figure, partition each shape into fourths. Partition each shape into fourths. So using your pencil or a pen and you have your printout in front of you, give it a whirl and we'll see what we can do. Pause the video and come back. All right, this is how I did it at first. I do a straight line down the middle of each side, so on the top and across the side, and cut them into fourths. Notice that each large item is cut into 4 equal parts. We will call then each part a fourth. Using the same shapes and a different cut pattern for each figure, partition each shape into fourths as well. So pause the video, see if you can do it a different way. And maybe your first way was a different way than mine. So the second way I did it was to go across them. So in an X pattern on each one. Even though the resulting shapes after being cut are different, each shape is cut into 4 equal parts or fourths.